In this video, we're going to look at some advanced exponent rules. So we're going to start with looking at what happens when you're multiplying powers with the same base. So here are some examples. If we have 2 to the third power times 2 to the fifth power, and we write that out, we have 3 2's being multiplied, and then we multiply that by 5 2's being multiplied together. Well, if you look at what we have in total, we have 8 2's getting multiplied together, so that's 2 to the 8th power. And note that 3 plus 5 equals 8. In this next example, we have 3m to the 5th power times 7m to the 9th power. So multiplication is commutative. We can do it in any order. So let's do the 3 times 7 first. That's 21, just regular rules of arithmetic. And then when we have the m's, we have 5m's multiplied by 9m's, and 5 plus 9 is 14. So our final answer would be 21m to the 14th power. And I like to use the metaphor of animals joining forces. So for example, if we have penguin squared times penguin to the 7th power, that's penguin to the 9th power. P squared times p to the 7th equals p to the 9th. So let's look at some examples. Let's jump down and look at number E, letter E. So we have 5e to the 3rd power times e to the 11th power. Well, the 5 is just going to stay a 5. And then e will be 14, 3 plus 11. Those elephants are going to join up. There's 14 elephants. Let's look at letter G. 10g squared times 7g to the 13th power. Well, 10 times 7 is 70, so we're going to use the normal rules of multiplication for that. And then for the giraffes, we're going to use our exponent rules. 2 plus 13 is 15. Letter H, similar. 3 times 5 is 15. And then we have our hippos. We have 8 plus 23 is 31. And finally, letter I, our iguana problem. We have 9 times 11, that's 99. And then we have 14 plus 18, that's 32. All right, our next rule, raising a power to an exponent. So let's say we have 2 to the 3rd to the 4th power, right? This outside 4 tells us we need 4 of this base, 2 to the 3rd. So we need 2 times 2 times 2, 4 times. So 3 2's, 3 2's, 3 2's, 3 2's, 3 plus 3 plus 3 plus 3 is 12, or 3 times 4 is 12. So when you're raising a power to an exponent, you can multiply the two exponents. Now for this next one, we have 4m to the 9th to the 3rd power. So that tells us we need 3 groups of 4m to the 9. So the tricky thing here is with the 4, we're just doing the regular rules of arithmetic. 4 times 4 times 4 is 64. Then for the m's, for the monkeys, we basically have 3 groups of 9 monkeys. That's 27 monkeys. So our final answer would be 64m to the 27th power. And I like to think of the parentheses as like a cage. So this 3 tells us we need 3 cages, and each cage has 2 tigers in it. So when we bust them loose, we're going to have 6 tigers. All right, let's take a look at some of those examples. We'll jump down to letter E. 5e to the 8th power squared. So we're going to break it into 2 pieces. 5 squared is just 25, 5 times 5. And then for our variable, we have e to the 8th power to the 2nd power. That's like 2 cages of 8 elephants, that's 16 elephants. 2 times 8 is 16. For letter F, we have 2f to the 17th power to the 5th power. So we're going to break it into 2 pieces. 2 to the 5th power is 2 times 2 times 2 times 2 times 2, that's 32. And f to the 17th power to the 5th power is 17 times 5, which is 85. 5 cages of 17 flamingos is 85 flamingos. All right, let's look at letter G. Here, the 3 only applies to the base. It doesn't apply to this 2 that begins the problem. So first we're going to leave the 2, and then we're going to do 3 to the third power, that's 27, and 6 monkeys, 3 cages, 6 monkeys is 18 monkeys. And then we can take one more step because we can multiply the 2 and the 27 and get 54. So that would be our simplified answer, 54 m to the 18th power. All right, for letter H, we have 2 options. We could first simplify what's inside the cage and then apply this 3. Or we could apply the 3 first and do 3 times 8 and 3 times 17. I think it's a little easier to simplify the cage first. So let's just simplify the cage. Instead of saying we have a cage with 5 and then 8 hippos and 17 hippos, let's just say we have a cage that has 5 and 25 hippos. 8 plus 17, using our rule from the previous page. And then we're going to do to the third power. So 5 times 5 times 5 is 125, and 25 times 3 is 75. All right, our next rule is looking at if we're dividing powers with the same base. So in this first example, we have p to the 11th power divided by p to the 8th power. And if we wrote that out, we would have 11 p's on top getting multiplied and 8 p's on the bottom getting multiplied. Well, p divided by p is 1, right? So it's not going to look very clean, but basically these 8 p's on the bottom are going to cancel out 8 of the p's on the top, and we're left with 3 p's on the top, or p to the third power. Note that 11 minus 8 is 3. So when you're dividing powers with the same base, you can subtract the exponents. I like to think of this as an animal battle, where the top of the fraction is good and the bottom of the fraction is evil. So we have 11 good penguins battling 8 evil penguins. The 8 evil penguins each kill one of the good penguins, and in the end, 3 good penguins are left standing. All right, this next example, we have 12m to the 7th over 15m to the 12th power. Now, the key for this is to remember that for the coefficients for the regular numbers, we apply the regular rules of arithmetic. So if you saw 12 over 15 and were asked to simplify that, you would divide them both by 3 and get 4/5, right? So we get 4/5, and now we're going to do the monkey battle. And here, there's 12 evil monkeys battling 7 good monkeys. So the evil monkeys are going to win. 12 minus 7 is 5, and the 5 survivors of this battle are evil monkeys, so they're on the bottom. Here's just more explanation of the metaphor. If we had m to the 9th over m to the 7th, we'd have an answer of m squared, or m to the 2nd power, because the 7 evil monkeys kill 7 of the good monkeys, 2 good monkeys survive. So they're on the top. But if they're on the top, we don't need to put a 1 in the denominator, right? We can leave that off. All right, let's take a look at a couple examples. Let's look at letter D. We have 8 and 18, so we're going to simplify those as we just simplify a normal fraction. 8/18 simplifies to 4/9. We can divide them both by 2. Now we have the dinosaur battle. And we have 4 minus 3 is 1. And there were more good dinos to start with, so that 1 dinosaur is going to be on the top. And we don't need the 1 if we don't want to put it. We could leave that off if we want. All right, let's look at letter F. Letter F is a double battle because there are different variables. There's an F variable and an M variable. So 3 steps. First, simplify 7/14. We get 1/2. Now let's have the flamingo battle. 15 on top, 2 on the bottom. 15 minus 2 is 13. 13 survive, and they're on the top. Monkey battle. 21 minus 11 is 10. So on the bottom, we're going to have m to the 10th power. And that's our final answer. All right. Final rule we're going to look at is negative exponents. The most common error students make are they think negative exponents are going to turn the expression negative, but they do not. Negative exponents are a way to show repeated division. They do not turn an expression negative. So k to the negative 7th power tells us we want to divide by k 7 times. The way we can show that is by putting 7 k's on the bottom of a fraction to show division, but we can't have a fraction with nothing on the top, so we're going to fill in a 1 here. So the negative 7 basically sends the base k down to the bottom of the fraction, and the exponent becomes positive. Let's look at this example, second example. We have 5 over 3j to the negative 27. So the 5 and the 3 are untouched, and the j goes to the top and becomes positive 27. So I like to think of negative exponents as signifying that that animal is a double agent. So these 27 jaguars on the bottom, right? They seem like they're evil, but since it's a negative exponent, they're double agents. They're actually good jaguars. So we need to move them to the top and make it j to the positive 27 on the top of the fraction in the numerator. So here we have this dog fraction, d to the negative 5 over d to the negative 9. So again, we just move these 5 dogs from the top to the bottom because they're actually evil dogs, and these 9 on the bottom are actually good, so they move to the top. And then we can battle it out and do 9 minus 5 and get 4. So at the end of this battle, 4 good dogs survive. All right, let's take a look at letter E. We have e to the negative 6 over 4e to the 15th. Well, these 6 elephants on the top need to move to the bottom because they're actually evil. And they're going to join the 15 elephants who are already on the bottom to make 21 evil elephants. Now we have nothing on the top, so what do? We have to fill in a 1 to hold the place. Let's go back to letter C to illustrate this principle that for here, this negative 3, unless you have parentheses, the exponent is only attached to what's directly beneath it. So it is not this negative 3 exponent does not touch the 26. So the 26 is going to stay there. And these 3 chickens are double agents. They're going to go to the bottom and become c to the positive 3rd. All right, letter F. Here, what I recommend doing first when you have negative exponents is just first move them to the correct side. So 20 over 15 becomes 4/3. Now let's just move the exponents. So we have f to the 26. The f to the 12 is going to go to the top from the bottom. And then the m's, the monkeys, are going to change places. So this 34 is going to go to the bottom. And this negative 20 that was on the bottom is going to go to the top and become positive 20. And now we're going to battle it out. We're going to have, I'll write it down here. We have 4 and 3 stay. The flamingos, there's 38 who team up on the top. And the monkeys have a battle. 34 evil monkeys battle 20 good monkeys. 14 evil monkeys survive.